I got a question about how we can use XSteam. How does it work? So let me show you. So first you have to download MATLAB on your computer, and I'll make another video for how to do this. But let's assume we already have MATLAB on our computer, right? So use MATLAB, and in the homework there was this XSteam MATLAB package. You download this from Canvas, you unzip it, and once you unzip it, you will find there's xteam.m and xteamus.m. That's just units difference. So we're gonna run this guy. Okay, I'm double clicking it. Here it is. This is a package that basically give you the Steam table. All right, so if I run it like this, you will add it to the pass, you will get an error message, nothing's working, because that is the Steam table that require numbers. You need numbers from you in order to be able to give you something back, right? So in the home, what numbers do we want? So in our homework, I give you the code already that I would like you to run. This guy. So if I copy this and I put it here in the command window and I hit run, it runs. You get the number. Okay, what number? What you asked him to do? You asked him to calculate the x2 and the t2 and the s2, knowing the p2 and the h2. Okay, that is the format of XSteam, the way you call it. And now he runs because we have XSteam already in there. Okay, so we run it in the command window. That is fine. We got the number. But a more neat way to do it is to put that code in a file by itself. And then you can save that file later on. You would say save as, and say you would call it H1 homework 1 problem 4, right? And you can save it over here so that you can later play with it, and you can even make the code more complete. What's more complete? You need to calculate H2. Why he's just being assigned H2, right? Maybe we should calculate H2. How do we calculate H2? We said in the homework problem number 3, we apply the first law of thermodynamics, which said H1 plus V1 square over 2 equal H2 plus V2 square over 2. So if someone would like to get H2, it must be H1 minus, plus V1 square over 2 minus V2 square over 2. Okay, and that is neat, but we need H1 and V1. So before that statement, maybe we should give him what is H1 and what is V1 and what is V2. You guys need to put the numbers right from the problem. What was V1? Was it 50 meter per second, and V2 was 600? I don't remember. You guys will check, right? And let me put this. This is for comments, huh? When you do this, you are allowing to add comments on that line, and so we will use that to remind ourselves what is the unit of that thing. And view H1 would be what unit? We said we always use SI. Okay, so then H2 now is calculated in joule per kilogram. That's perfect, huh? That is SI. However, unfortunately, XSteam need things in kilojoule per kilogram. Fine. Once we calculate in joule, then maybe over here we would convert it to SI. So over here you would say H2 is H2 divided by 1,000, and then it will become in kilojoule per kilogram. And then you send it to the XSteam, and he will start giving you the value. Right? Now this code is running it for different pressure. He's doing a loop over the pressure. We don't need all this. We just need one pressure. So you can knock down the foreign end and just write one P2, one pressure from the problem, and you get the X2 and the T2 for yourself. Okay? That's all it takes. Now, what if you are wondering what is why the XSteam is written like this and what is the thing in pink? This is all in the in the manual here. So in that package, after you unzip it, there is XSteam for MATLAB.pdf. If you open it, he will show you all the different formatting that allow you to calculate what? The temperature, the pressure, the enthalpy, the specific volume, the density, the entropy, the internal energy, the specific heat, all those guys can be calculated if you follow the correct format. So for example, if I want to calculate the temperature, you say you can get the temperature from the pressure and the enthalpy, or the temperature from the pressure and the entropy. So here we are getting it from the pressure and the enthalpy because we know the pressure and enthalpy. That's how we can use them to calculate the temperature. But there will be cases where we would actually maybe not just know the pressure and the entropy. Has this problem been isentropic? And then I said, well, calculate the velocity for me. So I don't give you the velocity V2, but I said it's isentropic expansion in the nozzle, calculate the velocity. Then what will happen? Then from 1, we go down isentropically. Then at 2, we know the pressure and the entropy, right? And so we will do something like this. At 2, we know the pressure and the entropy, which will be the same as entropy at 1. So that S1 will be the same. I will be able to say, this is not our homework. I'm just saying if we said the problem is isentropic, it's not. But if it was isentropic, I would have said S2 equal S1, right? And here, when I come up with, when I would like to calculate the temperature, what I'm gonna say then? I'm gonna say I wanna do it with the pressure and the entropy. That's what I have. I'm gonna say pressure and entropy, S. And rather than giving him B2 and H2, I'm gonna give him B2 and S2, right? And the same thing for the quality. So that, look at the quality, X. So you say here, the quality, you can get the quality from knowing the pressure and the enthalpy. That's what we did. But has this problem been isentropic? We would get it from what? From the pressure and the entropy. So here I would say the X is, give me the X from the pressure and the entropy. And I will end up sending him S2. Okay, why it's like this? That is the way the code understand. The people who made this code made that formatting so that the code would know what is he sending me, what does he want back. So he understand from this that you're giving him the pressure and the entropy and you expect the X from it. Okay, very good. So now if the problem is isentropic, then we don't need S2. S2 is S1, but what we need is the enthalpy. So you go here and you will tell you, well, here is how you get the enthalpy. You can get the enthalpy from the pressure and the temperature, or the pressure and the entropy. That's what we want. So I would say, well, then H2 is gonna be, what is the format? H of underscore B and S. So it would be H underscore B and S, right? That's what it say. And then I will get the enthalpy at 2 from knowing the pressure and the entropy. Okay, so now I calculate H2, and knowing H2, again, we are solving now in this example. I'm saying if the nozzle was isentropic, I'm gonna take this, and then at the end of this, I'm gonna calculate not H2, we just calculate H2. I'm gonna calculate V2 from it, right? So this equation will be rewritten such that we now know H1 and H2 and V1. Let's calculate V2. That would be the best velocity ever when the nozzle is isentropic. That would be the maximum velocity. Does this make sense? Okay, so this is just a steam table, and those are the formatting that you use in order to come up with any reading, any variable that you want from 2 variables. Do we always have to have 2 variables? Yeah, any state is defined by 2 variables, but you know, in the steam dome, there is saturated, the edge is saturated vapor and saturated liquid. When you are saturated liquid and saturated vapor, you don't really need 2 variables. It's just enough that you know it is saturated, and here is my pressure. Give me everything. So when I'm saying it's not really two variable, it's implicitly included two variable. Why? Because when you say saturated liquid, that means X is 0. And when you say saturated vapor, X is 1. So what you see over here is that, like for example, over here, you say if you have saturated vapor, all you need to give us is the pressure. And that's the format. You'd say H capital V underscore B. He will give you saturated enthalpy, saturated vapor enthalpy, knowing just the pressure. Why only one variable? Because it's already implicitly known that the X is 1 for saturated vapor. And the same thing for HL. If you know you are saturated liquid, you just give him the pressure. And that's it, one variable. So you don't pass two variables, you just pass one variable, which is the pressure, and you give him that format. All right? Very good.